Welcome everybody to my talk. This talk is about loading modules everywhere is the topic, and why I think SystemJS is the way to go today. So my name is Gion Kunz. I'm a front-end developer working for Odeven. We are a startup company, started 2 years ago. And some of our business is developing front-end for medium to large enterprises, and we kind of help them to ramp up on modern front-end trends and tools. So what is all this module hype all about, right? So we know modules for quite some time, but what is this really all about in JavaScript, right? What are modules? So I think we need to go back in history a little bit, in code structuring history, when we were writing our front-end applications in JavaScript. So let's say we go back 10,000 BC, and this is probably how we were writing JavaScript applications back then, right? So one huge file, all our functions and variables inside of this file, the whole state in one file. And our application was not really structured very well. We had really issues maintaining our applications. So it's probably a bad idea, right, to write JavaScript like this. So this rage face expresses that was a very bad idea. If we go further in time, maybe 5000 BC, it looked like this, maybe. So we thought, yeah, we need to structure our JavaScript, right? So let's create individual files for each individual piece in our application, and then we are loading all these files in the browser. Seems to be a good idea, but however, it's not really, right? Because we are having a huge connection overhead like this, and this is really not performant. And then we also have the order of inclusion, which is kind of dictating the dependencies and all this, which is not really a good idea. So rage face for this approach as well. Okay, so now we moved quite a bit on, let's say the medieval of module loading or structuring our applications. And we came up with these kind of approaches, right? So we are creating namespaces in JavaScript on the window object, and then we fragment these namespaces. So we have sub-namespaces, and we're adding our modules to these namespaces on the go. And then we can have individual files that are responsible for one single namespace, and then in the end we are just concatenating all these files together, and we have a nice structured application, but in the browser we just have one JavaScript file, which was actually the start of something that I don't need to put a rage face on here right now, right? So this is quite a good approach already. And then moving on, let's say 2000 AD, we even invented stuff like this. So this is the revealing module pattern, so that we can even have information hiding inside of JavaScript modules using closures, using function closures. So you have a kind of a private area in our module, and then we have a public interface to that module. So this is already nice structuring. But let's move on. And now we are in the present. So the previous approaches, there were something like modules. They were a little bit module-like, but were not real modules. So what do we have today? Today we have real modules, right? And this is really amazing. So now we have real modules, and I'm going to show you some of them now. But first, let's just quickly check how can we use modules to structure our JavaScript applications. So this is a simple example of an ES module, of an ECMAScript module. So it's the ES6 standard for defining a module format. And here we have just two modules, a module A and a module B. In module B, we do a named export. We export a function called doStuff. And then in module A, we import this function doStuff. We do a named import, and then we are executing the function. And like this, we can really structure our whole JavaScript application really nicely. So there are a few anti-patterns I would like to talk about. So how many of you are Java developers here? 80, oh, okay, 70, 80%. Okay, so I really think there are a lot of anti-patterns in Java, really. Because Java, I like Java, I have a Java background as well. But Java is really, you only have classes, right? You have nothing else than classes. So you don't have a structural tool to bundle some functions or some variables into another container than a class. So you need to use classes to create something like this, like a utility class that contains static methods, right? But actually it's a complete anti-pattern. Why would I use a container that is there for inheritance to store some static functions, right? The functions could exist on their own. They don't need a class. So this is just for structuring because you don't have anything else in Java. I consider it very bad, actually, because classes are there for inheritance. If we look at modules, the same code as we saw with the class is actually represented here as a module. We're just exporting these two functions because that's the element we are concerned about in this module. Another anti-pattern, I think, is a singleton. Who of you have developed their own singleton classes? Everybody, right? We've all done it. But actually, it's really an anti-pattern. Why should we use a singleton if we have something like a module? Because a module is only instantiated once, and after that it's cached, so it is already a singleton. So the same code that you see here, like a counter singleton, can easily be implemented as simple as this. We have a module with a local variable, count, and then we export two functions to increment the count and one to read the count. And that's our singleton because the module is only instantiated once. Okay, let's look at the different module formats very quickly that we currently have. We have AMD, and AMD is probably the oldest module format. It was getting really popular with require.js. And if you look at the code, it's actually quite cumbersome to define these modules, right? Okay, it's not that much code, but imagine you have a lot more code and a lot more modules. It's quite some boilerplate. And also you can see that you need to define the factory function, then you need to return whatever you want to export. In the imports or in the define dependencies, you need to really create an array with the name of the dependencies, and then you can get these let's say, injected into your factory function. So it's quite cumbersome. And this is definitely a contrapoint to AMD. So you have a quite a verbose format to define modules. Also, they can't really handle cyclic dependencies. I mean, require.js came around with it a little bit with dynamic requires, but still the module format, AMD is not really made for handling cyclic dependencies, which is a bit of a pain. Definitely a pro is that it's kind of an inversion of control, right? When you define a new module, it's not executed immediately. It's put into a registry, and the registry is then resolved on when all the dependencies are resolved of that module, the factory will be executed. So it's kind of an inversion of control, which is really nice for a module loader. Okay, let's look at CommonJS. I think CommonJS modules you all know from Node.js, right? So if you have done some Node.js development, you were using this syntax of saying require something or export something, right? Module.exports or just exports, and then you say require to import something. So you can see it's quite a simple format, right? You have these two things, require, module exports. It's really simple. So that's definitely on the pro side, it's a very simple format. However, the problem with CommonJS is that it is designed for synchronous operation, right? When you require something, it needs to be there immediately, right? So there is even not an inversion of control, because when you say require, it will just get into the other file immediately and then kind of execute in this other file. If you have other requires there, it will also get into these files and execute it on the go, right? And whoever is first to load a module, this will be let's say the the responsible code that caches or puts that other module into the cache, and then going forward it will be also cached. But this whole flow of immediately executing this dependency tree is not really ideal for a lot of situations and in order to solve some problems. So let's look at the last of the three module formats, which is ESM. And this is the ECMAScript 6 module format. I'm definitely most excited about this module format because it just supports so many different things, and it's really, really clean. And it's standardized, which is always great. So here we have a named import. We import do something from the module B, and we execute the function. It's really clean. There is syntax support, so we don't need to use an API. It's really syntax that we can use. We have default exports, named exports, bindings, right? So if we update something in the module internals, the other modules that depending on it will be immediately updated because exports are always bindings, right? This is really cool about ES6. It's great for static analysis, right? Because of the syntax, you can easily analyze it. And they now support, the specification now is onboarding this dynamic imports, which was something missing, but now they're getting there. And there is also tree shaking. So what the heck is tree shaking? I didn't know, so I thought, okay, I'm gonna take my dog and go into the woods because I live very close to the woods. And I did some tree shaking. And really nothing happened, except that my dog was looking at me and he thought I'm really, really crazy human. So my dog is, I think he's pretty smart. So I thought, okay, I'm gonna explain to my dog what tree shaking is really all about. So tree shaking is really simple, actually, if you think about it, because the ES6 module format is so easily statically analyzable. We can easily eliminate all code that is not used in our runtime. So if we look at this example, we have our main module here importing only A from the const module. So if that is our entire application, we can easily analyze this code and say that we don't need B and C, right? So the final product that goes into the runtime of the browser doesn't contain B and C, right? We can eliminate any that code automatically. And that's what tree shaking is all about. All right, so now how do we go from modules, from these module formats, into the browser? So actually, there are quite a lot of bundlers or loaders for the browser, right? So there are two basic approaches. One approach is a bundler, which is taking all the modules and putting them into one single file, which is then being put into the browser. That's a bundler, right? And then you have loaders. They are loading modules on the go asynchronously within the browser, right? And in the beginning, you could say, or some time back, you could say, this is a bundler, this is a loader, right? But nowadays, things have changed a little bit because loaders have recognized that bundling is a really great thing, and bundlers have recognized that loading is a really great thing. So they came together a little bit, except for some exceptions. Like Rollup.js, for example, is really only made for creating bundles. That's the only purpose of Rollup.js. It's only for ESM, so you can only bundle up ES6 modules or ESM modules. And it's also supporting tree shaking. On the other hand, we have a pure loader, which is the ES module loader, for example. And the ES module loader is currently under specification, right? So there is a specification that is now being created for that. So it's always hard to compare these bundlers, and I get asked a lot, should I use Browserify or Webpack, or what should I use? And it's hard to compare them, and you need to tell all the details about things. So I think for me, it's easiest if I compare it with these Pokemons, actually. Because on the left-hand side, you have required.js, which, yeah, is a little bit neglected now, I think, because the project is quite old, right? And it was purely built as a loader. Then there was R.js to optimize and bundle up your application. But the module format support is maybe not the latest, and they're really not able to keep up with the latest module trends, I would say. So it's a little bit, poor guy here, a little bit neglected. And Webpack is like a big monster that supports everything, right? You start it and it comes with a dev server, so you have a dev server, you have Webpack, and its intention initially was really to create one single pack. That's also why it's called Webpack, right? With all your resources, and that was the main idea. And then later on, you could use like text extract plugin to get stuff out of that pack. Of course, chunking was there from the beginning, but still, yeah, it's a big, for me, it's too monolithic. I don't like monolithic tools. On the other hand, we have Browserify, which for my taste is a little bit too modular. And for all my Browserify projects, my configuration files were really like growing like huge because I needed to use so many different loaders and plugins and stuff. And then we have SystemJS, and actually I couldn't find a better image than a burning unicorn to represent SystemJS, because it can just do so many things in such a simplistic way, and that is what I really want to show you today. So coming back, we start with the ES module loader specification. So this specification currently is worked on, but I think it's there for the last 4 or even more years. So it's there for a long time. And actually, Guy Bedford, who is one of the people really working on SystemJS, I mean, he's the creator of SystemJS and all this whole ecosystem. He was observing this specification from the beginning on. And the specification is really all about this. So the ultimate goal is that within our HTML, we can just write a script type module and then src and the URL to a module. And then the browser will be able to load this file, and he knows that this is a ES6 module, so he will load it as a module. That's really the ultimate goal where we want to get. And the cool thing is that Guy Bedford, as I told you before, he created a polyfill for that, right? So he created a polyfill for that specification, the ES module loader specification, that you can just load into your browser like this. So here we are getting it locally. We have stored these 2 files. We load the bubble transpiler, and then we are also loading the polyfill, the ES module loader polyfill. And after that, you can write something like script type module and a source. And this is really great because now we can load these modules in the browser. And if you look at the code that we load, here we're loading module a.js, right? So if you go to module a.js, you can see we can use ES6 imports, right? Import message from module B, and below we have module B where we export a constant message. And this is already working in the browser like this. So that's really nice. And we can also take a look at browser support today, because that's kind of surprising, because Edge 15 has full support for script type module when you enable it in the flags. And even more surprisingly, Safari 10.1 has support without even a flag. So it's already integrated in the latest WebKit, right? Which is really cool. In WebKit, you can already do that without the polyfill, say script type module. This is just quite recently, I think, maybe a month ago or not even, they added this feature to WebKit, which is fantastic. So now, since we have a module loader specification and we also have a polyfill, why do we need SystemJS then? Because then we can load modules already in the browser. So the problem is not the tool itself, but our environment, right? Because we have so many different module formats, and if we use the web as a library, we have npm, Bower, we have GitHub, we have so many locations where all these packages can be located, right? And then maybe this library is using that module format, and another library is using a different module format, right? And so this is really the problem, so that we need to be able to handle all these different cases. So SystemJS was created exactly for this purpose. It's building on top of the ES module loader, but it adds on some features like loading different module types and also supporting different cases like do they export default export in the main entry file and things like this, right? So this is really a great start because we are building on the specification, but we are adding more stuff to that. So it's a universal dynamic module loader that loads ES6 modules, AMD, CommonJS, and global scripts in the browser and Node.js. That's also very important. You can run SystemJS from Node.js, or you can run it in the browser. And that's really a cool thing because in the browser you can use it to load modules directly. And in Node.js you can, for example, use it as a build tool because then you can, instead of loading these modules and passing them into the browser runtime, you can bundle them up into one single file and then distribute this file, right? So as SystemJS is universal, we have the opportunity to load it in the browser or to have it in Node.js, which is really, really great. All right, so let's see how we can load a CommonJS ES5 module inside of SystemJS. So we are adding SystemJS as a dependency here. We added it from a CDN directly. We load it in the browser. And then down in our body here, we are using system.import to import our main entry module. So this is all happening in the browser. So we say system.import module A, and then let's look at module A.js. We have almost the same example as before, but this time with require.js, right? So we say require module B.js, get the message property out there, and then put it into our body. And this is really all it needs. So this already runs perfectly fine. We have module support in the browser by just using this simple script, which is great. I mean, imagine all the tooling work we do today. Like 50% of my time sometimes as a front-end developer goes into tooling, right? While working on a project. This is horrible. I mean, tools are great, but I don't want to spend 50% on tooling, right? So using simple tools like this, which are universal, makes it really, really great to develop fast. So this is a good use case for this. We're using npm CDN. So this is a CDN that hosts all the npm packages that are available, really everything. So we could do a little trick and use SystemJS to configure a path like we do here. We configure wildcard path npm:, and then we say this should point to npm CDN, where all the npm packages are located. We configure also Babel transpiler, and then we import our main.js module. So let's look at our main.js module, what we're doing here. So now what we can do is we can directly import the merge function from the Lodash module that is hosted on npm CDN directly in our code, right? This is easily possible with SystemJS because it fetches all these modules asynchronously with HTTP requests. We're also fetching JSON markup, and then we are merging two objects in this example using the merge function from Lodash. We are formatting this object into formatted highlighted JSON HTML markup and put it into our HTML, right? It's really simple, but we already did quite a lot of stuff with only a few lines of code, which is really, really great. All right, one more thing from SystemJS. SystemJS comes with some kind of extensibility, so we can have so-called loader plugins where we actually hook into the hooks that are defined by the ES module loader specification. These are these 4 hooks that are provided in the loader specification. Resolve is responsible to resolve a module name. So if I say require A or import from A, then this A is getting passed to the resolve. And resolve needs to tell, okay, A is probably a.js in the current folder, for example. So it needs to be resolved to a URI. And then fetch takes this resolved address and fetches the content of the file, the text content, let's say. Translate is then there if you want to translate something. So if you are running a transpiler or a preprocessor, you have the chance to translate the source file and produce kind of an output file, or content. And then instantiate finally is there to take that source that was probably translated and create a JavaScript object out of it, right? So it evaluates this source code and exports or generates a module object. So this is the purpose of the instantiate hook. So if you look at a simple plugin we can implement easily, this is a text plugin. With this text plugin, we can load text files or strings, text in any kind of files, using this text plugin as JavaScript modules. So here we say import content from content.html !text.js. So SystemJS will just recognize the exclamation mark and it will assume that text.js is the plugin that we want to use, the loader plugin that we want to use to load this text file. And in the implementation of text.js of the loader plugin, we are implementing two hooks. The first one is the fetch hook, so we are using the fetch API to fetch the text content of the file that is loaded. And then in the translate hook, what we need to do, we need to make from this text, from this string, we need to make a JavaScript module from that. So what we are doing here is we say we are constructing a CommonJS module default export by saying module.exports equals quote, and then we put our string that we have just loaded from the file content, and then we close the string again. So like this, we can create a simple text loader plugin. And then after that, we can load templates or CSS files directly as modules into JavaScript. All right, there is still more. So this is, we have the ES6 module loader polyfill. Then we have SystemJS that handles the complexity of modules, of different module formats, of this whole environment we are in currently with all this diversification and fragmentation in the module section. So SystemJS can handle all this. However, if you are using 20 libraries and you need to maintain all the configuration in SystemJS on your own, it's going to be quite a lot of effort, right? You need to check each module. Is it CommonJS or ESM? Does it export default or not? What is the entry module? And you need to configure all this in SystemJS. So there is another tool also by Guy Bedford called JSPM. So it's a JavaScript package manager, and it's a node tool that allows you, it's kind of a broker between all the packages in the web as a library, if you like, and SystemJS. And what it does, it just downloads these packages and generates SystemJS configuration for all these packages, which is great because then we don't need to manage it on our own, and we can also download packages from the internet instead of just relying on npm CDN as we saw before, for example. So this is a great addition. All right, so I think it's time for a little demo. So what I want to show is I've built a small application. Actually, it's a video game. So I've built a video game using TypeScript because I wanted to really explore TypeScript to its kind of borders, and also SystemJS and JSPM. So I think creating games is always a good use case because yeah, it involves a lot of design patterns, and you need to, create a lot of complex patterns to load stuff, to defer stuff, and all this, and rendering. So it's a really simple tile-based game where you can actually collect coins. And you also have physics, so I can jump around, but also the tiles support different physics environments. So this is like an ice tile, right? So I can slide on this ice. And there is also like water, so I'm kind of floating here in this water. It's hard to get out sometimes. Also here is like a slime block, so I'm really stuck in this slime. This is like, sometimes it's also hard to get out of that. And I can collect these coins. However, there is something missing about that. It's not really nice to play yet. So I thought, yeah, what's going to be the natural next step for this game? So maybe to load patterns, to load graphics, right? So I have implemented this using SystemJS because I wanted to test if I can easily load these tile-based graphics using SystemJS. So I came up with this universal graphics loader plugin, which is using a little utility function that I've created, load binary data, which is working on Node and in the browser to load an array buffer from a file URL, right? So like this, you can load the array buffer of a file URI, so the binary data. And now in SystemJS, since it's universal, we can always check, are we currently in a builder phase, right? So is this running on Node.js and we are building this whole thing? Because then we need to do something different. In this case, our graphics loader is actually a data URI loader that will actually, in the browser, directly use the address that we are importing. So if we are importing test.png, then this address will get into the image source, and we receive this image source from the module export. However, when we are bundling a JavaScript, one bundle, we need to do something else because we cannot put the PNG directly into this bundle, right? So there what we are doing is we create base64, well actually a whole data URI which contains the base64, and put this into our bundle, right? So we kind of distinguish between the two processes. Are we in the browser? Because then we can shortcut, we can load the files directly. Or are we in Node.js and we are building with System Builder? And then we need to create text which gets into the JavaScript bundle. So that's what we're doing here. And then in the translate hook, which is responsible for creating the source code for the module, we are creating an image. And now we are just using the data URI text that we are created in the fetch and put it into the image source here. And this is then created as a CommonJS module export. Finally, we have the instantiate hook, and the instantiate hook is only there in the browser because the bundle doesn't need to instantiate. It just needs to create the text representation of the translated module, and this needs to get into the bundle. However, instantiation is part of the browser game, right? So this is only browser, not builder. So here we can just take the shortcut and say that our image we are exporting is having the real address of our import. All right, so let's look at our game, how this looks like. So now we are loading these tiles using our data URI loaders or our universal graphics loaders, and it already looks a lot more like a game, right? It has some graphics tiles, slime is even animated here, and there is the water, and it almost looks complete. However, I think there is still one important thing missing, and that is actually this satisfaction that when you get a coin, right? Because I think it's not that it disappears, it's more this audio sound that you get when you walk over these coins, right? This is really, I would say, more than 50% of the satisfaction playing Super Mario, right? So let's look into that and how we could do that easily with SystemJS. So now, for this, we are creating a loader that will return the array buffer of an MP3, right? So we are loading an MP3 from either locally when we are running on Node.js and building the bundle, or we are loading it directly in the browser, right? When we are running in the browser. So here we have a little bit a different shortcut when we are in the browser. Here we are directly putting this binary data we get from our load binary data function into a so-called metadata of the module. This is available in SystemJS, so we can put the metadata or we can add information to the metadata, and later on in the hook process we can extract this metadata again. So here we're taking this shortcut. For the builder part in the translate, again we are putting together a module exports that is decoding base64 again. And if you're not in the builder, we don't care about the translation because we're taking the shortcut. And now we are in the instantiate hook again. And here we are only in the browser again. So there we are now just extracting what we have previously put into the metadata. So the whole binary data object, and get the array buffer from there. So now let's look how that looks like, or better, how that sounds like. And I hope the audio is a little bit okay because I'm recording it with the microphone here. So now you really have the satisfaction of collecting coins. And since we've done this with the web audio API, it's really cool. I don't know if you can hear it, but it sounds like Super Mario is a little bit in a cave right now. There is some afterhull, some kind of... This is a convolution effect from the web audio API. So I've used this to create tile-based audio environments. So when you are on a regular tile, you have a cave-based audio environment. But now if you jump into the water, you are kind of soaked under. And this is all done with MP3s and impulse responses and using the web audio API. So I can get out again. Or Mario sometimes is even a DJ. So if he's not sure if he should swim or dive, he starts to DJ a little bit with the equalizer, if you like. So yeah, that's pretty cool. So we've implemented all this, or I've implemented all this with the loader plugins. And this is really cool, and it shows the flexibility that we have using these loaders. I can run my application in the browser, all files get loaded individually, and then I can use Builder. As long as I build my loaders universally, they will transpile into one bundle, and then it works out really nice. Do we still have time? Okay, cool. So now actually what I would like to show you is a small demonstration of using the JSPM tool, just that you see how this building process works, how this builder process works. This is actually pretty simple to use. Here we have the whole TypeScript project that I was talking about. So I wanted to do everything on my own, also the physics and rendering. It's not the most performant one, but it's a lot of fun to do this, and it's a good test drive for any language and things like this, because you're using a lot of edge cases. So now if we look at that project, we have here our main entry file, or first maybe this configuration file generated by JSPM. So everything you see in here, nothing special, is just SystemJS configuration. The JSPM config file is SystemJS configuration. As I said before, JSPM is just the broker that generates configuration for SystemJS. And here you can see all the mappings that are used for building and also for running this thing in the browser. So it creates a lot of mappings. This is in NPM, this is in GitHub, and all these kind of mappings. So our main entry module here is main.ts, and in main.ts we are actually importing a CSS file using the CSS importer. That is also a, let's say, a core plugin that was created by Guy Bedford. And it's loading the CSS as text, and then it's exporting something that will add a link element into the head and encoding the whole CSS in there, right? So that we can have CSS embedded in our HTML directly. So maybe this is not always a good approach, but for a game that I want to have it really self-contained, it's really nice to do it like this. Then we import our main engine, and we are adding some basic markup here to the HTML body, or to the body element, and we start our engine, and this basically starts the whole game. So if we are now moving to the console and we are using JSPM build, we can say that it should also minify. And now we need to provide the path to the main module, to the entry module, right? Which is src main. And now we are letting it build. So that takes a moment. It will grab all the files, resolve everything, linking everything together, and then creating one single file for us. And in there is everything is embedded, right? The PNGs, the MP3s, all is embedded in that JavaScript. So now JSPM is done. So what I will do now to prove you that the whole game is in here, it's quite large, so WebStorm is giving me a warning here. I will just copy this code, and I will go to a blank JS bin. It doesn't even have HTML, right? And I'm just pasting this into JS bin. Let's see what happens. takes some time. It's 1 megabyte or even more. Okay, it's there. Yes, nice. Our game now runs in JS bin, right? So we have already had it there. Cool. So this is really cool that you can run applications in the browser directly, load everything separately. You're developing quite fast. If you change a file, only this file causes a reload. You can use live reload or something like this, and then you load your applications again from individual resources. However, if you want to have a production build at the moment without HTTP2, maybe in the future this is changing, but at the moment it's still a good idea to bundle as much together as you can. So using System Builder is a really nice thing here, and JSPM. All right, that's almost the end here. I use this time here, I have also, before we go into the question, to advertise 2 of our workshops that we are planning upcoming in March. So on the 17th and 24th, I'm going to do 2 Angular workshops. The 17th is a beginner's workshop, and 24th is an advanced workshop. So if you are looking for a workshop in Zurich about Angular 2, please come to our workshop. It's definitely going to be great. And especially for Fox Days, we have a discount code FOXED. And if you register with this discount code, you get 10% off from the workshop price. All right, thanks a lot. Questions?
How is SystemJS working with like React.js and AngularJS? Are there any troubles or?
Not at all, no. There are no troubles because SystemJS works with Babel and TypeScript transpiler, right? So you can easily use Babel transpiler, and then JSX transpilation is not an issue, and you can easily use it as a loader for React.js. AngularJS, they have even, I mean Angular 2, they even started to use SystemJS as their main transpiler. They have even, for the router, for example, they have used SystemJS to compile, to load different routes, right? So they have even a hard-coded dependency somewhere in the core code. I was working in this area a little bit on the source code on Angular, and I saw that there. So I think they're really compatible with SystemJS really nicely. Yeah, I'm also using SystemJS with Angular 2 a lot. Actually, it's our preferred loader and bundler, so we use it in a lot of Angular projects. Yeah. Also, all their examples on Plunker, they use SystemJS to start the application. So, yeah. Yes. Any other questions? Oh, I know this guy. Hey, Roman.
Do you know in what direction the Angular team is moving with the CLI? I think they are using Webpack currently, right?
Yes, they do. I really don't know. The CLI is a bit different project, right? And I'm not quite sure where they're heading to there. I have actually no idea. And I would also not recommend to use SystemJS when you use the CLI, actually, because the CLI is already there to provide you a full-blown solution to develop Angular stuff, right? So I wouldn't really recommend to use SystemJS in combination. Maybe if you develop an Angular application and you want to build it up, your tooling a little bit modular, then SystemJS is a really nice candidate. But if you decide to use the CLI to build up your application, it's probably not the right choice. And yeah, sorry, I don't know about the strategic direction there with the CLI. Sorry, I couldn't answer. All right. Thank you. And have a nice day.